Mars colonization, reality or science fiction? For centuries, humanity has gazed at the night sky, wondering if we could ever live beyond Earth. Among all the planets in our solar system, Mars has captured our imagination the most. But is colonizing Mars just a wild dream, or could it become a reality within our lifetime? With companies like SpaceX and NASA making significant strides toward interplanetary travel, the idea of humans living on Mars seems closer than ever. But how realistic is it? In this video, we'll explore why Mars is our best option, the major challenges we'll face, the groundbreaking technology needed, and whether we could one day terraform the red planet into a second Earth. Let's take a journey into the future and explore whether humanity will truly become a multiplanetary species. 1. Why Mars? Among all the planets in our solar system, why is Mars the most viable candidate for human colonization? 1.1. Similarities to Earth. Red circle a day close to Earth's. Mars has a 24.6-hour day, making it easier for humans to adapt. Snowflake frozen water. Scientists believe large amounts of ice exist under the Martian surface, a crucial resource for future settlers. Globe showing Europe-Africa a solid surface. Unlike gas giants like Jupiter and Saturn, Mars has a rocky surface where humans could build settlements. 1.2. Why not other planets? Yellow circle Venus is a hell's cape. With surface temperatures exceeding 470 degrees Celsius (878 degrees Fahrenheit), and an atmosphere filled with sulfuric acid, Venus is far too extreme for human survival. Blue circle Europa and Enceladus are too cold. These icy moons may have underground oceans, but their extreme cold and distance from the sun make them challenging options. So, while Mars is far from perfect, it remains our best chance at establishing an off-world colony. 2. The harsh reality of living on Mars. Before we start packing for Mars, let's address the huge challenges we need to overcome. 2.1. The hostile environment. Fog-thin atmosphere. Mars' atmosphere is 100 times thinner than Earth's, meaning there's almost no breathable oxygen. Cold face extreme cold. The average temperature is -63 degrees Celsius (-81 degrees Fahrenheit), far colder than Antarctica. Warning radiation exposure. Without a magnetic field, Mars is bombarded by solar and cosmic radiation, which could cause long-term health issues for humans. 2.2. Deadly dust storms. Mars experiences massive global dust storms that can last for months, blocking sunlight and reducing solar power efficiency. 3. How can humans survive on Mars? To establish a permanent colony, we need breakthrough technologies to make life on Mars sustainable. 3.1. Transportation and spacecraft. Rocket. How will we get there? Currently, it takes about 7 months to travel to Mars. But future spacecraft using nuclear propulsion could shorten this time significantly. 3.2. Martian habitats. House living in domes. To protect against radiation and extreme temperatures, early settlers will likely live in underground shelters or pressurized domes with oxygen production systems. 3.3. Producing water and oxygen. Droplet extracting water from ice. Scientists plan to use electrolysis to separate water molecules into oxygen and hydrogen. Seedling growing food in Martian soil. Plants will require hydroponic farms and nutrient-rich soil to grow in the harsh Martian environment. With these technologies, a self-sustaining colony may be possible, but only if we can solve one of the biggest challenges, energy production. 4. The energy problem on Mars. Battery solar power won't be enough. Mars is farther from the sun, meaning solar panels produce less energy than on Earth. Dust storms also make solar energy unreliable. High voltage the best solution? Nuclear power. NASA and private companies are working on small nuclear reactors that could provide consistent energy for Martian settlers. Could nuclear power plants be the key to long-term survival on Mars? 5. Terraforming Mars. Can we make it like Earth? Some scientists believe we could transform Mars into a habitable world by thickening its atmosphere, warming the planet, and introducing liquid water. 5.1. 3 possible ways to terraform Mars. Sun melting the ice caps, Releasing trapped CO2 could increase the greenhouse effect and warm the planet. Cyclone artificial magnetic field. Mars lacks a natural magnetic shield, but could we build an artificial one? Seedling planting life on Mars. Some bacteria and hardy plants might survive in Martian soil and slowly release oxygen. However, even the most optimistic estimates suggest terraforming Mars could take centuries or even millennia. So the real question is, should we even try? 6. The ethical and political debate. If humans colonize Mars, who will be in charge? Will it be run by governments, private corporations, or independent settlers? Busts in silhouette. Who owns Mars? According to the Outer Space Treaty of 1967, no country can claim ownership of another planet. But as private companies plan missions to Mars, new laws may be needed. Globe showing Europe, Africa. Should we focus on Earth instead? Many argue that humanity should focus on solving climate change and global issues before expanding to another planet. Others believe colonizing Mars is essential for our long-term survival. Conclusion: will we ever live on Mars? So, is Mars colonization a reality or just a sci-fi dream? White heavy checkmark. Current technology makes short-term missions possible, but a permanent settlement is still decades away. White heavy checkmark. Scientists are working on better life support systems, habitats, and energy sources to make colonization feasible. White heavy checkmark. Terraforming Mars may be possible, but it would take centuries, if not longer. Would you move to Mars if given the chance? Or do you think humans should focus on fixing Earth first? Let us know in the comments.